Hi, I'm Nancy from the Weizmann Institute of Science. Our work on machine learning prediction for the diagnosis of ALS and FTD by a signature of 18 circulating microRNAs has been done in collaboration with Andrea Malaspina, Jonathan Warren, and Pietro Fratta. The delayed diagnosis of both ALS and FTD is the main motivation to our work. Diagnostic biomarkers are desperately needed in neurodegeneration. Circulating microRNAs, which are small non-coding RNAs, hold a fascinating potential to act such as a diagnostic biomarkers. Therefore, we conducted the largest profiling study of cell-free microRNA by enrolling ALS and FTD patients and healthy controls. Here, we overcome limitations of previous work by performing unbiased next-generation sequencing on a big cohort, followed by machine learning algorithms. We aim to develop a multi-disease prediction model that is able to distinguish at the same time between ALS, FTD, and controls. We started with 132 microRNAs measured in the plasma and applied machine learning techniques to discover the top predictive ones. We ended up with a small set of 18 microRNAs with the highest diagnostic power in both ALS and FTD. Based on those 18 microRNAs, we have developed a multi-disease classifier on a training cohort of 371 subjects. The multi-disease classifiers exhibits a high area under the curve of 90% on average. We then wish to test whether the classifier predicts well on a replication cohort. We kept 124 subjects as a holdout, and we saw that the multi-disease classifiers performs well also on unseen data. We then followed by a post-hoc analysis of those high-risk factor microRNAs, and we asked ourselves whether those microRNA are shared between ALS and FTD, such as, for example, miR1, or there are disease-specific ones, such as miR206, which contributes much more to the risk of developing ALS. We then looked whether up or down regulation of those microRNA increase the risk. So for example, miR206 is upregulated in ALS cases versus controls. In summary, we have developed a multi-disease model using advanced ensemble machine learning techniques based on data of cell-free microRNA profiling of almost 500 subjects and discovered a diagnostic biomarker which is composed of 18 circulating microRNAs. Some of those microRNAs are interestingly shared between ALS and FTD, while others are disease-specific ones. Such classifier will allow the early stage detection of high-risk individuals and may facilitate drug development in clinical trials. Thank you very much for listening.